Okay, we're going to talk about how to find the area of a regular polygon. And there's a real formula, and then there's kind of, for me, the easier way for me to do it. So the formula is the area is equal to 1/2 little a, which is something called the apothem, and big P, which is the entire perimeter of your shape. Now, let's go and find out what an apothem is. If you draw yourselves something that sort of resembles a regular pentagon below, we can label all the parts. So the apothem is the altitude of the triangle that's drawn there. The A stands for apothem, it will stand for altitude, and it will conveniently stand for the adjacent side when we have to use trig ratios. So A is just the altitude of that little triangle there. Now this R that seems to be hanging out, you may need to use it, and I wanted you to know what it is. It stands for the radius, which seems silly to be using in a polygon, but it comes from the notion that if you inscribed this regular polygon in a circle, that line would be a radius of the circle. So when you draw it from the center to a corner of your regular polygon, that's called a radius, just in case they give it to you. Now, the way that I actually do these problems is I find A, and I find the area of this triangle instead, and then I just multiply that number by the number of sides. So in this case, we have a pentagon. If I find the area of that triangle and I multiply it times 5 triangles, that's the full area of the shape. Both of them are actually the same thing, so you use what you find best. Let's do an example. Now, you cannot put this example on here. I will let you put the instructions on here, but you gotta get another piece of paper out to just practice this. So let's take a pentagon whose side lengths, so we have a pentagon, its side lengths are 12. So the first thing we're gonna do is, step 1, draw a triangle. I'm going to draw this triangle in here. Step 2 is to find out, we're going to draw in the apothem too. Step 2 is going to be to do 360 divided by the number of sides. Which is called n, so we could do 360 divided by n. And if we do 360 divided by 5, we're going to get 72. That means there's 72 degrees in each of these corners. We don't actually want 72. What we want to do after that is, step 2b is, divide that number in half. So we really want the 36 degrees that are right there. And that's because now we have a little right triangle that we can use trig ratios to find any missing sides. We know that the side lengths of the pentagon are 12, so that means this little piece is 6. Okay, the whole bottom is 12, but this little piece would be 6. So step 3 then is use trig ratios to solve for A, or I call it P, girls, this little piece down here. But we know what P is, it's 6 in this case. So we are going to set up a trig ratio. As you can see, I have labeled my triangle with an OA and an H, and the apothem conveniently, like I said, is going to be the adjacent side. So I have O and I need A, so I'm going to be using tangent. So let's write a little trig ratio. We're going to write tangent 36 equals opposite 6 over adjacent A. Now, when I do this, I'm going to want to do a division problem, all right? So we're going to do 6 divided by tan 36. And when we do that, we're going to get a big, long number. So you're going to get that A is approximately 8.25 with a whole bunch of numbers behind it. I'm going to write either 8.2 or 8.25, but I'm not going to use this number. Use the number in your calculator, not this. If you're not going to use the number in your calculator, I'm going to ask that you actually round it. You don't round it, that you write it to 3 decimal places and use 8.258. Now, when we do that, we're going to get, after we get A, you're going to put that either into the formula, which is 1/2 A times the perimeter, which is 12 times 5. All right, that'll get you the perimeter. And when you do that, you should get that the area is around 247.75 square feet. I rounded it. It was 0.748, so I rounded to the nearest hundredth. I do want to show you, though, that the method I use, where I use the area of the triangle and then multiply it, it's the same thing. What I do is I say, I'm going to get the area of the triangle, which is 1/2 base times height, and the base is 12. Because remember, you would use the entire side, girls, not just the 6. 1/2 base times height, which is A, and then times 5 triangles. If you look, we've used the same things. We've both used 1/2. We've both used an A. We both used 12. And we both used 5. So whichever formula you prefer, please use it. Now check out the next slide to find out why you want to use the entire number in your calculator for the A. Now continuing with that same triangle, that same pentagon and little triangle here, I want you guys to see why I said that you shouldn't just round it off so early. These are the answers to the problem. So when you use what's exactly in your calculator, you get 8.25 with a whole bunch of numbers behind it. Now it's okay to write A is equal to like 8.2 or 8.25, but you want to use the number that's actually in your calculator. You want to continue with it. So when you do that out, you get, if we round it to the hundredths place, 247.75 square feet. Well, if you only used 8.2, you would say it was 246. You're off by almost 2 whole square feet, which is a lot of space. Being a little bit more accurate, 8.25, you're going to get 247.5. And then finally, if you use 3 decimal places, you get very, very close to the same number. You get at least, this is what it reads in the calculator. When you get this, you can see in the red above, it says 247.74 with the 8 behind it. So at least you're much closer. So if you can't do it by continuing to use the answer in your calculator, I would say if you're rounding something to the hundredths place, I would say it's best to write it out to 3 decimal places, because you're going to be at least a little more accurate and you're going to get close to the same answer as everyone else. So here, I want you guys to not panic. When you have the area of a dodecagon and you think, good Lord, how am I going to draw that? Who said you had to ever draw that? Good Lord, no. What you're going to do is you're going to go with step 1, which is to draw a triangle. That's the only part you need to do. And just remember, the dodecagon means 12 sides. As long as you know that, who cares what it looks like? So all you have to do is draw the triangle. So we're going to draw this triangle. Its side lengths are 12, which means that this little piece is 6 again. This is still the apothem. Step 2 in our little adventure was to do 360 divided by the number of sides, which is going to be 12 in this case. And 360 divided by 12 equals 30. Well, that means that all of these triangles have 30 degrees. But we don't want the full 30. We want just this piece, which is 15 degrees, which is why we do step 2b, and we do 30 divided by 2, which is 15 degrees. And now, again, we're just going to use our trig ratios. So opposite is this side, adjacent is the A side. I'm going to again use tangent. So I'm just going to write a little tangent 15 equals opposite 6 over adjacent A. It's going to be a division problem again. So I'm going to do a little 6 divided by tangent 15 in order to get A. And I'm going to carry that number in my calculator. So when I put this in the calculator, I get that A is approximately 22.39. And it's okay to write that, but again, I'm going to use the number that's actually in my calculator. And I like to do it without the formula. So what I'm going to do is I'm going to say that since A is 22.39, I'm going to multiply that number by 6 because 6 is half of the original base. So if I just multiply by 6 by A, I'm going to get the area of this entire triangle. So I do A, what's in my calculator, just hit times 6, and I get around 134. And then I'm going to hit times 12 triangles, and I get that the answer is around 1612. It'd be great if I were using a pen, not a highlighter. 1612.245. So I'm going to round this thing up to say that my answer is 1,612 feet, 0.25 and a quarter square feet. So hopefully you got that answer. For those of you who love the formula, you would have gotten that crazy 22.39, doing 6 divided by tan 15, and then you would have just hit times 12 or times 144 because that's the perimeter, and then you would hit divided by 2. So you'd be good to go. Or you could just do A times 72, and we're going to get the same exact answer.